Good morning, everyone. And we are here in the final subtopic of chapter 7. And this year will be a little bit different from what we have before. So you need to pay attention because this is something new. We are also going to read the graphs in between. So pay attention. If you are not sure, you can ask me online, even on the classroom, so that everybody will benefit from this particular session. All right, so previously we spoke of expansion and contraction. We spoke about the three basic states of matter, and we also spoke about how Brownian motion comes into play in this case. All right, let's start. You know your four basic processes from solid to liquid, liquid to gas, all right? So we're just going to concentrate on these four because you will need to know and try to tie in with the particle of model, and that will be all your circular stuff, yeah? Okay, so let's have a look here. Now we know melting is solid to liquid, but do we know the process that happens in between? The first thing you have to do here is to see the particle arrangement. And in solids here, you notice all the particles are arranged side by side. They're very close to each other. Now, upon receiving heat, your particles will gain energy. Then when it gains energy, it vibrates a bit more vigorously. Right? And when it receives the energy and vibrates more, you notice that it will actually gain more energy, vibrates a bit more, and it will try to move away from each other. Okay? So what happens here in the process is that sufficient energy has been gained. And remember, all your particles are basically attracted with each other. So what you're trying to do when you gain the energy is to overcome it, right? So remember, if you are holding your hands together, you need an external force to break it apart. Well, not really breaking your hand, but trying to pull you apart. So this is the same thing in the melting concept here. So once the forces of attraction between the particles have been overcome, the particles will break free and it will move randomly. Now, there will be a point where you will say, okay, so if my solid changes to liquid, then wouldn't it be melting? You're absolutely right. And you'll be asking, wouldn't there be a certain point that, yes, you are correct. It's the melting point that has been reached. And remember, we have spoken about this in one of our earlier topics about melting point. It is the point where solid changes to liquid. Okay, so you can see here in terms of your particles, all of them are spaced very, very close together. There's not much of space in between. But as soon as you gain energy, you literally break apart those forces of attraction. And as a result, you will have noted that it will be spaced out a little bit more. Okay, and let's move on to the boiling part. Yeah. So from the boiling part here, you will notice that, hang on a second, okay, my liquid is moving randomly, very freely. Now, what happens if more energy has been gained? Obviously, the particles will have more energy and it will vibrate a little bit more. And of course, you need to gain a certain energy, sufficient energy to overcome the forces of attraction between the particles. Particles will eventually break free and it also moves randomly. And again, this is where a certain point is reached when you say, okay, my liquid is now going to change into gas, right? And this is when we say the boiling point has reached. Okay, so this is a whole idea and scenario behind the whole thing. And same goes for the um, what is it, condensation. Okay, is the opposite of boiling. You'll notice that I have placed the two processes side by side so that you'll be able to understand one gains energy and the other loses energy. All right, so therefore in this case for condensation, once the particles lose energy, of course it goes in the opposite. It moves much slower. The particles will come together, the forces will become stronger between the particles, and there will be a point where gases change into liquid, and that is the condensation point. Okay, and if we go back to the slide previously, we have it in the liquid form. Yeah, and the liquid form here, whoops, I didn't change this one, no good. Solid is not meant to be heated. Solid, how to say, solid is Let me just change this. The particles lose energy, vibrates less. Sorry about this. This was my mistake. All right. Solid is cool. That's right. Okay. So back again, your liquid phase, your solid will be cooled down. Particles will lose the energy and vibrates less. And as a result, they can't overcome the forces of attraction, and instead the forces of attraction builds up. So the particles will move much closer, move less randomly, and coming towards moving on a fixed spot. Okay. Now, as soon as it decides to say, okay, my liquid will change into a solid, that is when you will say a freezing point has been reached. And of course, you do know all these points, melting point and freezing point. They are both they are both 0 degrees Celsius with a catch. You got to remember, they are both zero. Depends on where you look at. It's not to say that, oh, why is freezing the same as melting? Shouldn't be different. No, it has to see what processes has occurred. All right. And after the freezing point, liquid changes to solid and all the particles have returned to a fixed position. Same goes for boiling and condensation. Yeah, you have your boiling point and your condensation point. Both of them are also at 100. But remember, it is the direction that you're looking at. Okay. Now, having said that, you won't be able to picture this in your head yet. So you need time, and especially this section, to really go through and see through new words, how you're going to write it down, because this is a lot of written and explanation and an explanatory topic. Yeah. All right. So I will introduce to you two different types of curves, the heating curve and the cooling curve. Okay. So as you can see here, heating curve of water, for example. Now we have started at a very low temperature and you notice that as time passes by, your temperature increases. So this is how you read a graph. As time increases here, and you notice that your temperature is also increasing. So if it increases this way, notice that you can see the slope is going up. All right, this is the part where the solid gains the heat. Particles will vibrate faster. And you notice after a while, there'll be a plateau. Now, this is where your solid changes into liquid. So this section over here is still in the solid form. The moment you see a plateau, this is where the conversion is taking place. Solid to liquid solid to liquid states are changing. Okay. And this is why it is in a plateau, is because heat energy is trying to overcome the forces that hold the particles together. Now, as soon as it increases over time, you will notice that the particles will move a bit more freely and we are now in a pure liquid phase. And as it gains energy, it will vibrate faster. And there will be a point as well where heat energy is literally trying to break the forces that hold some of the particles. Remember, there's some liquid particles which are together. And this is where we call it's a liquid gas phase. All right. And then you see there's a boiling point. As soon as the boiling point is reached and it goes way beyond that, the whole liquid will be boiled or evaporated or vaporized into a gas, right? Into the gas phase. So basically, the heating curve is where your melting and your boiling processes are taking place. So my idea behind this is that you need to write it down. So on a piece of paper, try to just trace whatever graph that you have here and go back to the first two slides to see how it would take place. Yeah. If you have any questions, please let me know through Classroom or even, through emails or even the line group. That's completely fine. Okay. And of course, you're talking about the cooling curve, which is the direct opposite of the heating curve. Again, steam in the gaseous phase will lose energy. Particles come together. All right. And there will be a point where it condenses. This is where gas turns into liquid. All right. Remember, the whole idea is that everything now loses energy. Heating is gaining energy, cooling is losing energy. And if you still think of the expansion and contraction, this is where the contraction is happening for cooling, for the cooling curve. The expansion is happening for the heating curve. Okay. So what you need to do is to read through, because it's the exact opposite. Okay. As I told you before, these two processes are opposite each other. So if you remember one process, The opposite here is the true self for that process. Okay. After reaching the condensation point, it will lose more energy. It will be in a liquid phase at this section here. And we will still reinforce this in class. It doesn't mean that today is the end and we are off. No, we need to reinforce your concepts that you got to remember. Yeah. And after a certain while, it will reach the freezing point where liquid turns to solid. And this is where it's in a liquid solid phase. And of course, further decreasing, you will have a pure solid. Okay. Now, if you are interested again, you can go back to the States of Matter PHET simulation interactive website that I've shown you. All right. Okay. So just now you had the states here. All right. You had the states here. Okay. So you can change into phase changes, and let's just try water because we're on the topic of water. All right. As soon as I increase this in terms of heat, do you notice that your solid changes to liquid, and your liquid here, you can see this random motion, you can see it's sliding past each other, but they are all still intact here, right? But as soon as we increase a little bit more, notice that it is gaining more and more energy, it's getting more heat, it's vibrating, it's moving a bit more randomly, and you can see that it is going all over the place. Okay, so please do play around with it. And because this section here is also about pressure, you might want to play around and say, okay, if I were to decrease my pressure here, all right, sorry, not decrease my pressure, increase my pressure, and you can see, okay, this is what happens if you have too much of pressure being pressure onto the gas particles. It will eventually explode. Okay, so return lead, and then we can restart it if we have to. Okay, so I hope you really enjoyed this session here. If you have any questions, don't hesitate to ask me. All right, thanks for listening. And if you have any further questions, don't forget to contact me or even talk to your friends by line group or by email. Chat with them and discuss. We will definitely go through this topic one more time, but this time we're going to do in an activity base rather than just, the normal lecture stuff. I find it a bit boring if I do that. All right. Thanks for listening. See you.